In this video, we'll be finding the derivatives of various functions involving logarithms of various bases. So in order to do this, we're going to use first this identity. So the logarithm base a of x is equal to the natural log of x over the natural log of a. This is the most general form of this identity, but we want to get our logs in terms of natural logs. And then we'll use this derivative formula, derivative of log base a of u with respect to x is 1 over u times the natural log of a times du dx. Okay, so these, the first is an identity that's pretty easy to derive. You can find that online or in a textbook. And the second is a derivative formula that you typically derive in a textbook or in a Calculus 1 class. So for our first function, we have y equals log base 2 of 6x. And so here our u from our previous formula would be 6x, and our a, our base, would be 2, and so dy dx, if we use our formula, is 1 over u times the natural log of a times the derivative of u with respect to x. Okay, so if we plug that in, we have 1 over ru, which is 6x, times the natural log of a, which for us is 2, times du dx, which is just 6. And so when we simplify this, our 6's cancel, and we have 1 over x times the natural log of 2. For our next problem, we have y equals log base 36 of e to the t minus log base 6 of the square root of t. So here we want to use this identity, log base a of x is equal to the natural log of x over the natural log of a, which was our base. So now we can rewrite our function y before we start taking the derivative. We can rewrite this first one as the natural log of the argument, e to the t, over the natural log of the base, which is ln of 36. And we can do the same thing with the next one. So here we have the natural log of the argument, which I'll write as t to the 1/2, over the natural log of the base, which is 6. And then we can use the properties of logarithms to bring down these exponents. So for the first term, we'll bring down a t and have t ln of e over ln of 36, which is just a number, minus, again, we'll bring down our exponent. So we have 1/2 ln of t over ln of 6. And now we can take the derivative with respect to x. So if we do that, the derivative of the first term, well, this is just a number, and ln of e, well, the natural log and exponential function are inverses of each other. So this is just 1. So we get our number out front, 1 over the natural log of 36, because it's just a number in front of t. And then minus the derivative of the second term. Here, this is just a number, so it will come out front. So 1 over 2 natural log of 6 times the derivative of the natural log of t, which is just 1 over t. And so we can write this as 1 over the natural log of 36 minus 1 over, and I can bring this to, so I can do the same property of logarithms to bring this 2 up as an exponent of the argument of this natural log, and this will be natural log of 6 squared, which is just 36. Okay, and then I have my t out front. So now I can multiply by t on top and bottom. So right here, I can multiply by t over t to get a common denominator. Then once I do that, I'll have t minus 1 over t ln of 36. Next function, we have log base 5 of 1 plus x natural log of 5. So again, we want to rewrite this. So we'll write this as the natural log of the argument, 1 plus x natural log of 5, over the natural log of the base, which is 5. And then we can take our derivative, dy dx. So natural log of 5 is just a number, so it will come out front. And then we're taking the derivative of the natural log of 1 plus x natural log of 5. So the derivative of the natural log of anything is just 1 over the argument times the derivative of the inside. Well, the inside is just 1 plus x ln of 5. The derivative of 1 is just 0. ln of 5 is just a number, so it comes out front. And the derivative of this is just ln of 5. Well, we have a natural log of 5 on top and bottom, so these will just cancel each other, and our derivative is just 1 over 1 plus x natural log of 5. The next function is y equals log base 4 of x times log base 16 of x. So we'll start off, as always, as rewriting this. So the first one can be written as the natural log of x over the natural log of our base 4 times, again, natural log of the argument x over natural log of the base 16. Now, if we actually multiply this out, this becomes the natural log of x all squared over the natural log of 4. And here I'm going to write this term, ln of 16, I want to write it as the natural log of 4 squared. Because then I can use the properties of logs to bring this 2 down and write this as 2 ln of 4. Okay, so now I have 2 times the ln of 4. Okay, so now my y equals natural log of x squared all over 2 times the natural log of 4 squared. Okay, so I can bring those together. Now if I take my derivative, I get 1 over 2 times natural log of 4 squared out front, since that's just a number. And then I need to take I need to use the chain rule to take the derivative of the natural log of x quantity squared. So the chain rule says take the derivative of the outer function, so bring down my 2, and then lower the exponent to 1, and then multiply by the derivative of the inside. The derivative of ln of x is just 1 over x. So now I just need to bring all this together. So here my 2's are going to cancel on top, and I get 1 over x times the natural log of 4 squared. Next function, we have y equals x times the cosine of log base 9 of x. So we want to rewrite this. So we'll write it as x times the cosine, and we're going to rewrite this log 9, base 9 of x. So this will be the natural log of the argument x over the natural log of the base 9. And now we can take our derivative, dy dx, and this is going to be a product rule. So it'll be the derivative of the first, which is just the derivative of x, so we get 1, times the second, or cosine ln x ln of 9, plus the first function, just x, times the derivative of the second. Well, this is a chain rule. The derivative of cosine is just minus sine ln x over ln 9. And then we need to multiply by the derivative of the inside. So ln of 9 will just come out front since it's just a number. And then we need to multiply by the derivative of ln of x, which is just 1 over x. Okay, so now we need to simplify all of this. So we'll get cosine natural log of x over natural log of 9 minus our x's are going to cancel here. Since they're multiplying, we get minus sine of natural log x over natural log 9 all over the natural log of 9. So in our next function, we have y equals log base 7 of the square root of 5x over 2x plus 3, all raised to the natural log of 7 power. So we need to rewrite this quite a bit. So we're going to pull out our 1 over the natural log of the base out front, since the argument is very large. So that's going to be times the natural log of the argument. I'm going to raise it all to the 1/2 power. So this will be 5x over 2x plus 3 raised to the natural log of 7, and that is raised to the 1/2. So now we can use our properties of exponents. So when we have x raised to the m raised to the n, this is the same thing as x raised to the m times n. Okay, so we can just multiply our exponents. So 1 over natural log of 7 times the natural log of 5x plus 2x plus 3 to the natural log of 7 over 2 power. And now we can use properties of natural logs, or just logarithms, to bring this exponent out front. So this becomes 1 over the natural log of 7 times the natural log of 7 over 2 times the natural log of 5x over 2x plus 3. Okay, so our natural logs are going to cancel, and now we have a quotient in the argument of our natural log, so we can rewrite that again. Okay, so now we just have a 1/2 out front, and this is going to be multiplying the natural log of the first function minus the natural log of the lower function, or the numerator. Put those in parentheses. Okay, and now we're finally ready to take a derivative. So if we do dy dx, our 1/2 is going to come out front, and then we just take the derivative of each term. The derivative of the natural log of any number times x is just 1 over x, minus the derivative natural log of 2x plus 3, which is 1 over 2x plus 3 times the derivative of 2x plus 3, which is just 2. Okay, so simplify that, we get 1 over 2x minus 1 over 2x plus 3. If we wanted, we could get a common denominator. Okay, so we can multiply by 2x times 2x plus 3 and get 2x plus 3. So multiply by 2x plus 3 on the left and by 2x on the right, and get 4x squared plus 6x. And then if we want, these two x's will cancel. We could write this as 3 over x times 4x plus 6. The next function, we have y equals log base 3 of cosine x times sine x all over 4 raised to the x times e raised to the x. Okay, so we need to rewrite this. So do what we did last time, 1 over the natural log of the base 3 times the natural log of cosine x sine x all over 4 to the x e to the x. So now we have a product in the numerator, and then we have that as a part of a quotient over the denominator. So we can rewrite this as 1 over the natural log of 3, and then we just need to add and subtract these. So we have the natural log of cosine x plus, since it's multiplying, the natural log of sine x, and then minus the natural log of the denominator. But both of these are raised to the x power, so I can just write this as the natural log of 4 times e raised to the x power. Okay, now I can use my properties of natural logs to rewrite that last term. So I'll just rewrite these, and I can bring down this x, and then this is just x times the natural log of 4e. Now I can take a derivative, dy dx, and get 1 over the natural log of 3 will just come out. Then the natural log of cosine, that derivative is 1 over the argument cosine times minus, times the derivative of cosine, which is minus sine, plus the derivative of natural log of sine x is 1 over sine x times its derivative, cosine x. And then the natural log of 4e, well, that's just a number, so this looks like a number in front of x, so its derivative is just the natural log of 4e, but I can write it separately, the natural log of 4 times the natural log of e. And the natural log of e just turns out to be 1. So I can write all of this as 1 over the natural log of 3. I'm going to write this term next since it's positive. So cosine of x over sine x is cotangent x minus this first term, which is sine x over cosine x. So that is tangent x. And then minus my natural log of 4 and minus the natural log of e, which is just 1. The next function, we have y equals 4 raised to the natural log base 3 of x. So here we need to take the natural log of both sides. So if I take the natural log of y and then the natural log of 4 raised to the log base 3 of x, now I can use properties of logarithms to bring down my exponent. So I get the natural log of y equals log base 3 of x times the natural log of 4. Okay, so now I'm going to just bring my natural log of 4 out front since it's just a number. And then I want to rewrite my log base 3 of x, so I'll do that as the natural log of x over the natural log of 3. Okay, so now I can take my derivative of both sides, but this is natural log of y, not just y. So we need to use implicit differentiation or logarithmic differentiation. So this becomes 1 over y times dy dx equals, this is just a number out in front. So natural log of 4 and natural log of 3 just come out front. And the derivative of the natural log of x is just 1 over x. So if we multiply by y and solve for dy dx, we get the natural log of 4 over the natural log of 3 all times y over x. So y, again, is just this. So it's 4 log base 3 of x all over x. The next function, we have y equals 5 times log base 32 of log base 2 of x. So this can be rewritten as 5 times 1 over the natural log of 32 times the natural log of the argument, which is log base 2 of x. Okay, now I need to pull out this since it's a number. Now I need to rewrite the argument of this natural log. So this will be the natural log of x over the natural log of the base, which is 2. Okay, so now if I take my derivative, this number will come out front, 5 over the natural log of 32. Okay, then the derivative of a natural log, you just do 1 over the argument. So this is going to be the reciprocal. So natural log of 2 over the natural log of x. So this, I just did 1 over the natural log of x over the natural log of 2. Okay. And then we need to multiply by the derivative of the inside. So our 1 over natural log of 2, just our constant's going to come out. And then we need to multiply by the derivative of natural log of x, which is just 1 over x. And now if we simplify all of this, our natural log of 2's are going to cancel, and we get 5 over x times the natural log of 32 times the natural log of x. Next function, we have y equals theta times log base 5 of e raised to the cosine theta times natural log of 5 power. So we can rewrite this as theta over the natural log of 5, so that's our base. And now we write natural log of the argument, so natural log of e raised to the cosine theta times natural log of 5. Okay, now our natural log and our exponent, since they're inverse functions, they're going to kind of cancel each other out. So we get theta over natural log of 5 times cosine of theta times natural log of 5. So these natural log of 5s are going to go away. And this function just can be simplified as theta times cosine of theta. And so if we take the derivative, dy d theta, we get the derivative of the first, which is just 1, times the second cosine of theta, minus the first times the derivative of the second, which is minus sine theta, or this is cosine theta plus theta sine theta. In our last function, we have y equals log base 6 of 9x raised to the natural log of 3. So we can rewrite this as 1 over the natural log of 6 times the natural log of the argument, which is 9x raised to the natural log of 3. So now we can use the properties of natural logs to bring this exponent out front. So this will become natural log of 3 over the natural log of 6, all times the natural log of 9x. And now if we take the derivative, this number out front just stays there. And then we take the derivative of the natural log of 9x, but that's just 1 over x. And so we can write this as the natural log of 3 over x times the natural log of 6. So I hope this video helped you see how to take the derivatives of various functions involving logarithms of different bases, and I hope it helped. See you in the next video.